Welcome, everybody, to this week's edition of 10 Weather Chat. I am joined this week by Dr. Bob Hatcher. He is a retired professor from the University of Tennessee. And today we're not talking weather, we're talking rocks, because we're going to talk about earthquakes that we have here in East Tennessee. So welcome to our newscast.
Oh, thank you. It's a pleasure to be here.
Or I should say our podcast. So first of all, for folks that don't know, we do have earthquakes here in East Tennessee. Can you explain a little bit about how many we see in a normal year and how we have earthquakes here?
Well, for comparison, the people in West Tennessee claim they can instrumentally detect 300 earthquakes in a month.
Wow.
The people from California say that's a good weekend for them.
Yeah, right.
and so here we have even less of a rate of occurrence of earthquakes.
Uh-huh.
So it's... we do not have that many here, but we do have earthquakes. There's no question about that. And we've finished a 14-year study of the East Tennessee seismic zone, and we demonstrated that there have been large earthquakes, larger than 6.5 in East Tennessee in the past.
Wow.
But in the last 10,000 years. So that sounds like a long time to a lot of people, but we could have a large earthquake tomorrow, and we don't know how to predict them.
Exactly.
That's the problem. So
you mentioned the East Tennessee seismic zone. That's not one specific fault. Like some people think of the San Andreas fault and the New Madrid fault. The East Tennessee seismic zone is a little broader than that, right?
Well, ultimately, earthquakes are caused by moving on faults and sudden movement, like releasing a rubber band and you feel it in your fingers. And that's the same thing as elastic waves that come off a fault moving. And so we do not know whether it's one fault or several deep in the crust where these earthquakes occur. They occur down 10 to 15 miles in the crust. They do not occur near the surface most of the time.
And our rocks here in East Tennessee are very old, right?
Yes. Some
of the oldest in the country?
No.
No? Where are some of the oldest rocks?
The oldest rocks in Tennessee are in northeast Tennessee, near Johnson City. And they're 1 billion years old.
Goodness gracious.
The rocks here in East Tennessee range from about 500 million years old to 350, something like that. These are millions of years. That's a lot of time, but that's the way we think in terms of time in geology.
And obviously, like you mentioned, in the past we've had some larger quakes. In recent history, we had a 4.1 magnitude earthquake just last year in the month of May.
Yeah.
And you said you slept through that earthquake?
I slept through it, that's right. People called me and said, "Did you feel the earthquake?" And I said, "No."
Well, it didn't rock your world, but for others, it definitely, we had lots of folks calling the TV station thinking there may have been a car accident or a car hit their building or something. And a lot of people reported hearing a sound with that earthquake.
Yes.
So do some earthquakes make noise?
Yes, they do. People describe it as a train coming.
Oh.
The noise sounds like a train.
Rumbling?
Yeah. They actually hear it coming, and then the noise passes, and that's the earthquake waves passing wherever they are.
Oh, wow.
Yeah. So there could be a sound with it, yes.
And so our earthquakes here in East Tennessee, while relatively low magnitude, can sometimes be felt over a larger distance at a lower magnitude than, let's say, in comparison to earthquakes in California. Why is that?
That's because the crust in the eastern United States is more intact. In the West, in California, for example, the crust is broken up by a lot of recent faults. Here in East Tennessee, we may have 10 faults at the surface, but they've been inactive for 250 million years. So the crust here is intact. The crust in Ohio, Indiana, and so on is intact also. And so an earthquake that occurs in East Tennessee would be felt up in Ohio and other places if it's a fairly large earthquake, a magnitude 4.5, say.
Yeah.
And the larger earthquakes that have occurred, say, in Charleston, South Carolina in 1886, New Madrid, 1811, 1812, were felt all over the eastern United States. And that's because the crust is so intact, and it propagates the earthquake waves quite well.
And so when you just mentioned the New Madrid fault, I think that's the one that anybody who knows a lot about earthquakes would recognize that name. And that's over in West Tennessee. Can you tell me a little bit about the history of that particular fault line?
Okay, well, Well, that's had a lot of study because they've had large earthquakes there. In 1811 and 1812, they had 4 earthquakes of magnitude 7 or above,
Holy
which is
smokes.
unusual even for California.
Yeah.
And these earthquakes that occurred there were damaging, except that hardly anybody lived there. The city of Memphis was very small. St. Louis was very small. And the earthquake was felt in both places, but it was not that damaging because there's so few people there. And it was, we know that, well, we only estimated the magnitude there. We did not have any direct measurement of earthquakes. We didn't have seismographs at that time. But we've been estimating the earthquake magnitude from the records that we can see, and the damage that's still there we can measure.
So I think I had heard something with that about liquefaction.
Yes.
Did that occur with the New Madrid earthquakes?
Oh, yes, a lot. As
Can
a
you
matter of
explain
fact,
that
when
to
you fly
people?
over the New Madrid area and the floodplain of the Mississippi River, you see a lot of round white spots there on the surface. And that's sand blows, sand that was released during the earthquakes in 1811, 1812.
What?
And the sand was water saturated, and so the weight of the sediment above that on the wet material below caused the water saturated sand to come to the surface.
So the shaking is what kind of allowed them to sift out?
And those are sand blows, and sometime I think they actually have water spouts coming up in the air for a time, not very long.
Wow.
They had those around Charleston also,
Holy
in South
smokes.
Carolina. Yeah.
Yeah, a lot of people may not realize that we've had some pretty big earthquakes in the southeast in the past. And that doesn't mean that they can't happen again in the future. So what causes the earthquakes? You said it's just the movement of the rocks?
Well, you have to have stress that builds up, and it's relieved by sudden movement on a fault.
Okay.
And that's what produces the earthquake.
And what causes that stress?
Plate motion.
The plate tectonics.
Yeah. The plate boundary that we think about is in California. That's the San Andreas Fault and others out there. In the eastern United States, we do not know exactly why we have earthquakes here or at New Madrid, but we do know we have them, and they have been occurring here for some time. In New Madrid, they think they have a recurrence rate of 600 years per large event. So we say that we've had them here in East Tennessee in the last several thousand years. So that's another issue as well. We have earthquakes because there's stress built up in the crust and it's relieved on faults. Why we have those earthquakes in New Madrid or East Tennessee, we do not know exactly. These are called intra-plate earthquakes. And the stress comes from the plate moving west, and of course it's buttressed by the Pacific plate in the western part of North America.
And that creates the stresses.
Well, the stress is built up behind that in the plate itself, and so that's why you have earthquakes within the plate. Yeah, so these are intra-plate earthquakes, and they're not as frequent as the earthquakes out west, but they do occur here.
And I've seen earthquake swarms in South Carolina.
Oh, that would be several earthquakes occurring over a short period of time, yeah.
What would cause a swarm like that to happen?
Again, stress being relieved on faults, one fault or more faults. And it has to build up there, and it keeps going and going and going, releasing stress and producing small earthquakes that are detected by the seismographs.
So when we talk about being detected by a seismograph, we're talking about the energy waves moving through the rocks. What does magnitude mean when we're discussing magnitude of an earthquake?
Okay, it's the energy released at the source. So
The epicenter.
No, that's
Not the epicenter.
That's the focus.
Oh, okay.
Epicenter is the projection of the focus to the surface.
Okay.
Yeah, and so you have an epicenter, and that's of course where surface damage occurs. But then at the focus of the earthquake is actually down in the crust where it actually occurs.
Fascinating.
So the energy released at the focus is what is measured by a seismograph, and the magnitude is expressed in numbers that have no upper limit to them. The earthquake that's detected, say it's a magnitude 3, is if we have another one that's a magnitude 5 shortly after that, it is not just two numbers greater, it's 900 times greater in energy release.
Oh.
So it's a huge difference there.
Yeah.
It is not a linear relationship.
Right.
It's a totally exponential relationship.
So what is, because I think, aren't some of the biggest earthquakes ever recorded above a 9?
Yes, yes.
In like Chile?
In Chile, there was one in 1980 or somewhere in there, at 9.6,
Oh
which
my
is
gosh.
huge compared to any place else. So
Wow.
when you talk about the magnitude 3s and 4s that we have here in East Tennessee compared to a 9 in Chile, it's many, many orders of magnitude greater in terms of energy release. And that's why there's so much damage, say, in big earthquakes around in Japan and Taiwan, Alaska even, and around the Pacific Ocean, Pacific Rim they call it.
The Ring of Fire?
Yeah, well, that's also volcanoes. Yeah, but
One of my other favorite subjects.
Okay. No, the earthquakes that occur are not necessarily connected to the volcanoes, but they're plate boundaries.
Yes.
Both are plate boundaries.
And some of those bigger earthquakes, because there's different types of fault movement. So some of them can cause tsunamis.
Yes.
So what type of an earthquake would create a tsunami?
Okay, it would be an earthquake that occurs under the sea. Probably, well, it could be near a coast, it could be far from a coast, but most of the time it's around a plate boundary somewhere, which is near coastlines. And the earthquake occurs, and it sends a wave through the water. And the water then builds up offshore and then comes onshore as a large wave, a tsunami.
Yeah, we experienced that in 2011 in Japan.
Possibly.
I believe it was.
That's the
nuclear power plant.
Yeah.
Yeah. And thankfully we don't have to worry about tsunamis here in East Tennessee, not being on a coastline.
That's right.
So that's a good thing.
That's right.
Do you have anything else you would like to discuss specifically about earthquakes? I mean, we're discussing it now, so there's probably some people who are at home going, can I prepare for them, or should I, or what should I know about them?
Well, I guess one question is, do I have earthquake insurance? And the answer is yes. It doesn't cost very much to add a small rider to your homeowner's insurance for earthquakes. So we live in an earthquake zone, so I have earthquake insurance. I didn't used to have it, and then I got when we did this research, I finally convinced myself to buy it, and we did. So we have earthquake insurance, and it's that's about the only preparation you can make, except the building codes in Memphis are very rigorous about building stronger to make sure earthquakes don't bring them down or they minimize the damage. Same in Charleston, South Carolina. Same, of course, even more so in California. But we don't have building codes here that account for earthquakes. We probably should have. So that would be something that would be very useful. If we had a big earthquake here, if we had a magnitude 7 here, it would bring down all kinds of buildings, and it would be very damaging. If we had a magnitude 6, same, it would be very damaging. A 5 is the threshold of damage. So if we had a magnitude 5, the largest earthquake to have occurred in the New Madrid seismic zone was in 2003 at Fort Payne, Alabama, magnitude 4.8.
Okay.
And we've had several 4.6s and 5s and things like that here in around Knoxville. Knoxville, Von Orr, Tennessee area has the greatest concentration of earthquakes in the East Tennessee seismic zone, but they can occur anywhere along the line that projects the seismic zone on the surface. So the seismic zone actually goes from northeast Alabama to here in the Knoxville area, and then it makes a turn and it goes into eastern Kentucky. They've had earthquakes of magnitude 4 or larger up there as well. And that's an area that should have some earthquake hazard written into it as well.
So I know I've been here for 10 years. And we've had several earthquakes that have been large enough to be felt.
Yes.
In the top 3-point somethings to low 4-point somethings since I've been here, including the one last year that was a 4.1 near Greenback. For folks that haven't felt an earthquake, could you describe what that feels like?
Yeah, you feel well, I felt one in my house. I was upstairs. If you're downstairs in the house, you don't feel it as much because the upstairs shakes more than the downstairs would. So I was upstairs one Saturday morning, getting ready to come downstairs, and the lamps on the dresser started shaking, and I could hear it. And I called downstairs. I asked my wife, "Are you doing something to make the house shake?" She said, "You're crazy," or something like that.
Yeah.
And so it's one of the few I felt. And you go to an area that, like California, you're likely to feel an earthquake because they have these magnitude 2s and 3s all the time out there, 4s.
I remember I think it was Martin Luther King Jr. Day in 2020. We had an earthquake here. And I was sitting at my dining room table. We had done a parade that morning. And I was sitting at my dining room table, and I heard a rumble. At least I think I heard a rumble. That's why I was asking you about the sound, because I don't know if my mind was like...
Quite possible, though.
Yeah, and it felt like everything moved, kind of a sway, and then it rumbled afterward. And I remember being like, I'm either disoriented or that was an earthquake. And then I checked the USGS site, and as soon as it came up, our newsroom went nuts with phone calls and emails, and it was an earthquake. Yeah. It was wild.
Now, there was an earthquake in North Carolina, in the mountains in western North Carolina recently that broke the surface, which is very unusual in the eastern U.S. And there was an earthquake there around 5 or something like that. But it broke the surface and produced a lot of damage just locally in the soil and that sort of thing. They could walk along it and see the damage that it produced on the surface.
And like you said, that's unusual.
It is very unusual. None of the earthquakes here in East Tennessee break the surface that we can see, except that in the past we have documented that there have been earthquakes that have broken the surface, but it's collateral damage, not as direct. It's not the direct producer.
Like land movement.
Yeah, that's right. But,
That's fascinating.
And, some of the photos I gave you have earthquake damage in them here in East Tennessee.
Wow. That's pretty impressive that we have had some large enough or impactful enough to have done that in the past.
That's some of the things that we've been documenting. We did some research that was supported first by the Nuclear Regulatory Commission, then by DOE maybe, and then by USGS. And this support covered 14 years of gathering data and that sort of thing. And one of the things that we demonstrated, the questions we were asking were, one, have there ever been large earthquakes greater than magnitude 6 here in East Tennessee? And we demonstrated, yes, emphatically, that there have been. Some of the earthquake faults that we have seen have as much as 3 feet of displacement on them. And
in East Tennessee?
Yes.
Holy moly.
There's one out on Douglas Lake that we found, one of the early ones we found. It's still one of the best ones. There's one down near the airport, same displacement. To get 3 feet of displacement, you've got to have an earthquake that's about 6.5 or larger.
Wow.
So we have had large earthquakes here in East Tennessee. Then the critical question is, how frequently do they occur? We did not tie that down. Some other people need to come and do the research and continue what we did and see if they can tie down the recurrence rate, we call it.
And I mean, I know our emergency managers, they plan for this stuff.
Yes.
They run drills about how they would respond to earthquakes. East Tennessee seismic zone isn't as great of a threat of a larger earthquake necessarily than the New Madrid Fault.
That's correct.
But I do know that our Tennessee Department of Emergency Management does.
New Madrid is a seismic zone just like East Tennessee. And so it's not just a single fault there. There are several faults, one of which cross-cuts the main fault that comes down the Mississippi River Valley. It cuts across it, and it's active also. So they've had a tremendous amount of support from the government over the last 30 or 40 years to do research in that area. A lot of people work on it. The only people who've worked in East Tennessee are us. They're myself, a geologist from the University of Memphis, a retired geologist from the U.S. Geological Survey, and a retired geologist from the Missouri Survey. And only 4 or 5 of us worked on it in that 14 years that produced what we did. We've published several papers on it.
And thank you for doing that, so that we can all be a little more prepared.
Made it better known, yeah.
And now, two more things I want to ask you about. Tuckaleechee Caverns.
Yes.
We heard that the rocks there and the seismometers that are down there can detect activity around the whole world.
Yes.
Is this true?
Right. That's right. If you have a seismic station like the one in Tuckaleechee Caverns, if there's an earthquake in China, we'll detect it here. But any place you have a major seismic station, which is that one is, earthquake waves come through the whole Earth. And that's how we know what we know about the interior of the Earth, is through earthquake waves. We don't have a way to drill holes down there or go and see.
Yeah.
So it's earthquake waves that give us the information on what's down in the deep Earth itself. And so by the velocities that they pick up, they can calculate velocity almost immediately. And then if you have 3 seismic stations, you can get the location of the earthquake exactly.
Wow.
A minimum of 3. You can't do 1 or 2.
Yeah.
Because the velocity gives you a circle. And so the circles intersect, 3 circles intersect in a point.
And that's how you can find it.
Yeah.
And so my last question for you, because this is a 10-weather chat, can the weather in any way, shape, or form influence earthquakes?
There's only one thing I would think of, and that is in areas where, say on the San Andreas Fault, where they have high rainfall, the San Andreas Fault is lubricated and it moves by creeping. It does not produce as many earthquakes. In the Southern California, where there's almost no rainfall, the San Andreas Fault is locked, and they're sitting there waiting on the huge earthquake that's going to happen when that energy is released. So that's the only way I could think of where weather could influence earthquakes.
Interesting. Yeah. Very interesting. Oh, frostquakes. Is that a thing?
What?
Frostquakes? When like water freezes and causes the rock to pop. They're probably...
Well, that's freeze and thaw. That's not earthquakes. No,
okay.
No.
They're just called frostquakes. They're not actually an earthquake.
No.
Okay. That's good to clarify that. Yeah. We get people sometimes during the winter that report pops and booms. And stuff like that. The mysterious booms of East Tennessee. We've never figured out what they are.
No. Well,
we get the reports periodically.
There's an area in Connecticut that has noises that frequently. It's a MOODIS, M-O-O-D-I-S area in Connecticut that has noises that are produced in the earth there that people hear. And I don't know if they've ever explained them properly, but that is an area that produces its own noises and has for decades and probably hundreds of years.
Science is so amazing, isn't it? The Earth.
It is.
And we're constantly discovering new things.
Keep learning things all the time, yeah.
Well, I learned a lot today. Thank you so much for coming in and joining us.
You're most welcome.
And thank you to everybody who's been watching for joining this week's 10 Weather Chat.